Hey guys, what's up? I hope you're having a great day, and today in this video I'm going to be going over Geometry Lesson 8-1. Now in this lesson we covered basically proportions in right triangles, and it got pretty confusing because what we're dealing with is pretty much this right up here. We're taking a triangle, and with this triangle they give us certain measures, mainly sides. And we need to figure out what the length of those sides are by creating proportionalities in the triangles. Now this can be difficult because of the orientation of the triangles. The large triangle ABC is a different orientation than the triangle CDB, which is a different orientation than the triangle CDA. Now if you want to, you can redraw all three triangles in the same orientation and do it that way, but either way, whether you do that or simply just do it in your head, it's going to take quite a bit of challenging thinking to try and figure out exactly how that's going to be rotated. So if we see this similarity statement here, I'm not really going to worry about the words, but basically what it's saying is certain lengths are corresponding. The thing to worry about is when you're comparing all three of these triangles, normally you'll only be doing two, right? So when you're finding one length, you're going to use all three, but when you're finding one length, you're only going to use two of the triangles. So what you're going to compare is the, let's say the short base of one triangle. So let's say of triangle number 1 to the same short base of triangle number 2 and triangle number 3. You're going to compare the long base, or I guess they're called legs, the long leg of triangle 1 to the long leg of triangle 2 and the long leg of triangle 3. You're going to compare the hypotenuse of triangle 1 to that of triangle 2 and to that of triangle 3. Now this is going to help you create the same proportions. So let's take a look at the similarity statement, and I'll explain what I just said a little bit better. Triangle ABC is similar to triangle ACD. Now what does that say? Well, it says AB, which is the large triangle hypotenuse. So it says AB is proportional to that of AC. Now we're looking at ACD for the second triangle, and it is the hypotenuse. So you're going from the big triangle hypotenuse to this triangle ACD to that hypotenuse. And if you go over to the third triangle CBD, CB is what's going to be proportional, and again, that is the hypotenuse. Now that works for BC, CD, BD, and AC, AD, and CD. Now, I don't really know how to teach you guys how to mentally rearrange certain things. What I can do is show you a little trick that helped me while I was trying. If you see how this triangle, this right angle, is cut, you have a larger piece of the right triangle cut on this side than on this side. So what you're going to end up with in these examples is a smaller angle and then a larger angle in terms of the other two angles besides the right angle. So let's say we're going to take CBD and compare it to triangle ADC. We need to overlap the right angles. So this is the right angle here of CDB. So we're going to need to mentally move this right angle over that right angle, right? We're going to need to align the hypotenuses of both. So this is the hypotenuse of ACD. CB is the hypotenuse of CBD. So we're going to need to align those. Then we're going to need to move the small angle onto the small angle. So when you rearrange it, you're going to have to kind of put CBD and D is at the right angle. So D is going to be here, B is going to be there, and C would be here, right? And you can see that let's see here, AC is to CB, right? So that's what's drawing these connections. As you can see, let's say AD, right, is to CD. So you can see how these triangles are being drawn. So it's going to create something. I'm trying to make it a bit easier. We're going to have the long side here, and then sort of a shorter side there when we flip it. What we're really going to do is flip the whole thing that way. And that's going to give us the new triangle orientation. Now, I'm sorry if you didn't understand that. I'm sorry if I took too long explaining that. But it's just something you need to grasp, is that by trying to move the AC over the CB and moving them back and forth, if you spend enough time thinking about it, it'll start to become clear, especially as you're doing examples. That's going to help. If you want a proof of why these three triangles are similar, you can look at this box down here and read the proof. Basically, what it's saying is that the right angles of all three of these triangles are congruent because they're all right triangles. A is congruent to A, which makes these two triangles congruent. And B is congruent to B, so these two triangles are congruent. And then by using the reflexive property of similarity, you can say that all three are similar and proportional. So that is the explanation of what we're going to be trying to do in this lesson. It is hard. It is going to take some time to try and figure out. Really, it's overlapping the orientations in your mind that's going to be a struggle. But if you remember what I told you, overlap the right angles, overlap the hypotenuses, and put the short side on the short side and the long side on the long side, or the short leg on the short leg and the long leg on the long leg. And you start to piece it together, and you look at these examples, and you look at the similarity statements they give us. I'm sure you can figure that out. So I hope this helped, and if you have any questions, let me know.